Hey everyone, today we're going to unlock a mental math superpower. We're going to look at a technique from the ancient Vedic tradition that turns complicated multiplication into something you can do in your head probably faster than you can even type it into a calculator.
Okay, let's just start with a problem. 97 times 96. Now, for most of us, seeing that means reaching for a piece of paper or, our phone. It just seems like a bit of a chore, right? But what if I told you there's a way to solve this in just a few seconds? Stick with me here, because the secret is in this simple, almost magical rule or sutra. It is a total game changer for how you look at numbers that are really close to powers of 10, like 100 or 1000.
All right, let's dive in and see how this elegant system actually works. It all starts by reframing the problem, not as complex multiplication, but as a super simple process of subtraction and just observation. So, this technique is called the Nikhilam Sutra, and its name, all from 9 and the last from 10, is actually a huge clue about how it works. It's a formula that's been around for centuries, and it was designed specifically for mental calculation. Okay, first up, we need a reference point. This is called the base. It's simply the nearest power of 10 to the numbers we're multiplying. So for numbers like 97 and 96, our base is going to be 100. For something like 998, well, that'd be 1,000. Super simple, right? Next, we ask, how far away are our numbers from this base? We call this gap the deficiency. So for 97, it's just 3 shy of 100, so its deficiency is -3. For 96, it's -4. And believe it or not, these two little numbers are all we're gonna need. And here's the absolute key to the whole thing. The answer is built in two super simple parts. We'll call them the left-hand side and the right-hand side. We calculate each part, and then we literally just stick them together. All right, enough talk. Let's actually do this and solve a problem. You're going to see just how clean and easy this two-part method really is. Okay, let's do one together. How about 98 times 97? New numbers, but the logic? It is exactly the same. Our base is still 100. So first things first, we set it up. The deficiency for 98 is -2, and for 97, it's -3. See, we've got our key pieces all ready to go. And here is where the magic happens. The steps are incredibly simple. For the left side of our answer, you just cross-subtract. You can do 98 minus 3 or 97 minus 2. It doesn't matter which one, you get 95 either way. Easy. For the right side, we just multiply those deficiencies together. -2 times -3, that gives us a +6. Okay, so we have our two pieces, 95 and 6. But wait, here is the most important rule of the whole thing. The right side has to have the same number of digits as there are zeros in the base. Our base, 100, has 2 zeros, right? So our right side needs 2 digits. That little 6 has to become 06. Now, you put them together, 95, 06, and that's it, you're done. Okay, so what about trickier numbers? Let's try 88 times 98. The process is going to be exactly the same, even though these numbers are a bit further from 100. All right, our base is still 100. The deficiencies, well, 88 is -12 from 100, and 98 is -2. For the left side, we cross-subtract. 88 minus 2 is 86. For the right, multiply the deficiencies. -12 times -2, that's a +24. And look at this. This is a perfect example of what happens when the right side naturally gives us 2 digits. The base is 100, 2 zeros. Our product is 24, 2 digits. It's a perfect match. No need to add any zeros this time. We just smash them together. 86 and 24 gives you 8624. You see the pattern now, right? Okay, so you've seen it work a couple of times now. Let's just lock in the rules, and I'll show you the one common mistake people make when they're starting out. Okay, 3 golden rules. 1, left side comes from cross-subtracting. 2, right side comes from multiplying the deficiencies. And 3, this is the big one, the number of digits on the right must match the number of zeros in your base. That's really the whole technique right there. All right, listen up, because this is super important. The number one mistake people make is forgetting to pad the right-hand side with zeros. Let's take 98 times 99. Deficiencies are -2 and -1. Multiply them, you get 2. And it is so tempting to just write down 972. But remember the rule. Our base is 100, so that 2 times has to be written as 02. The real answer is 9702. You gotta always check your zeros. Okay, and this is where the technique goes from being a cool party trick to an actual superpower. We're about to see how beautifully this thing scales up. Once you get the logic for base 100, you can do this for base 1,000, 10,000, whatever, with pretty much no extra brain power.
Let's try a big one, 998 times 996. So our base is now 1,000. The deficiencies are tiny, right? Just -2 and -4. The left side, 998 minus 4, that's 994. The right side, -2 times -4 is 8. Now, our base, 1,000, has 3 zeros, so that 8 needs to become 008.
And just like that, there it is. We put our two parts together, and we get 994,008. You literally just solved a huge multiplication problem with a tiny bit of subtraction and multiplication. I mean, that's the power of this method.
All right, you've seen the whole process now. From finding the base to building the final answer, you're totally ready to put this to the test.
Okay, your turn. The final challenge. Look at this. 9,997 times 9,994. A few minutes ago, this would have looked like a nightmare, right? But now, you've got the secret. You know the base is 10,000, you can see the deficiencies are just -3 and -6. You know exactly what to do. I bet you can solve this in your head before I even finish this sentence. You know, that feeling, it's perfectly captured by this quote. Math really can feel like magic when you find the right trick. Now, this whole sutra we just learned works perfectly for numbers below a base. But what do you think happens when the numbers are just a little bit above it? Something to think about. Thanks for joining us.